The second half of lesson 3.5 looks at adding and subtracting matrices, and it may include scalars with it. Given matrices A, B, C, and D, perform the following operations. First thing we want to do is just do a little refresher from the first part of 3.5 and add matrices B and C together. Now if we look at the dimensions for matrix B, notice right here we've got 3 rows and 2 columns. That's a 3 by 2 matrix. But if you look at matrix C, it's not exactly the same looking. Matrix C is 2 rows and 3 columns. Now the rule for addition is that the dimensions have to be an exact match. Therefore, there's no sum possible. The matrices have different dimensions. Matrices are just plural of matrix. So the matrices have different dimensions. And there you go. That's all you have to do. Now over here on the right, a couple of unique things that are happening. 2C minus 3D. Well, we already know C is a 2 by 3 matrix. And matrix D, if you notice here on the right, also a 2 by 3. So we know then that we can actually multiply them together. But in front of C, we've got a scalar of 2. So what I'm going to do is just put a 2 out in front of that matrix. 12, 0, 0, 0, 15, negative 9. And then I'm going to subtract 3 times matrix D, negative 5, 7, negative 3, and negative 4, negative 8, and 2. Now if I double matrix C, I'm really just multiplying all of my elements by 2. This shouldn't take very long at all. 24, but then 0 and 0. And in row 2, 0, 30, and negative 18. Now to multiply matrix D by negative 3, I'm actually going to leave the negative out of it, and I'm just going to triple everything in that matrix. So I'm just going to take the 3 itself. 3 times negative 5 is negative 15. 3 times 7, 21. 3 times negative 3, negative 9. And then in row 2, 3 times negative 4, negative 12. 3 times negative 8, negative 24. Ooh, lots of negatives in this one. And last but not least, 3 times 2 is 6. Okay, so now to subtract the 2 of them, what I want to do here is just take those corresponding elements, but remember, you're subtracting. So in my answer, if I take 24 minus negative 15, that would be 24 plus 15, which would actually be 39. And then 0 minus 21 would be negative 21. 0 minus negative 9 becomes positive 9. So in row 1, I've got 39, negative 21, positive 9. In row 2, I would have 0 minus negative 12, which becomes 12. 30 minus negative 24 becomes 30 plus 24, which is 54. And in that last element for row 2, column 3, negative 18 minus that 6 gives us negative 24. Here's our answer for the difference of 2C minus 3D. And that's how you would work with scalars and addition and or subtraction. For the last example, wow, I really am not sure what happened to the note packet, because in my notes from last year, I didn't have all those other numbers in there. So would you please first change matrix E to have the elements 5, and then 2x plus 3 is good, and then 3 in that first row. And then in row 2, I'm really sorry everybody, please have 5y, 8, and negative 2. All right, so from there, it says the directions say let A equal E. And what this means for us is that the 2 matrices would have equal elements. I'm going to use matrix A from up above, and that was another 2 by 3 matrix. That was 5, negative 7, 3, and then in row 2, 4, 8, and negative 2. Now, if the 2 matrices are equal to each other, I'm just going to set 5, 2x plus 3, and 3 in the first row, 5y, 8, and negative 2 in the second row, equal to then matrix A. So it's kind of rewriting the two matrices up above equal to each other. Now the rule would be if the matrices are equal, each set of corresponding elements would have to be equal as well. Now if we look at the first row 1, column 1, that matches row 1, column 1, so that makes sense. Not sure what I was doing with matrix E prior to that. But then in that row 1, column 2, notice I have 2x plus 3 and negative 7. Now that element, 2x plus 3, has to be equal to negative 7. And we can use this information to solve for x. Now it's just algebra. Move the 3 over, and we get 2x is equal to negative 10. Last but not least, divide both sides by 2, and x would equal negative 5. Just kind of incorporating a little bit of algebra within these matrices. From there, I have row 1, column 3, row 1, column 3, already a match. Now, in row 2, I have 5y in row 2, column 1, and 4. Again, by definition, those two elements have to equal each other. If 5y is equal to 4, to get y by itself, we would just divide. And it's possible to have your variable equal a fraction. From there, we've got row 2, column 2, row 2, column 2, they match. Row 2, column 3, and row 2, column 3, they match as well. We really just had to use the given matrices definitions to solve for x and y. And this completes the rest of the notes for lesson 3.5.